Section 9.1, starting chapter 9. We're doing distance and midpoint formulas today. All right. So right here we've got a set of ordered pairs. Remember, ordered pairs contain x values and y values, right? X value, y value. Well, if we're going to call this point 1, this is point 2, then this would be x sub 1 and y sub 1. This is x sub 2, that's y sub 2. Now, if I start talking about x1, y1, x2, y2, that's what we're talking about. All right, so we'll plot our first point. We're at 1, 2. That guy's going to be right about there. Our second point is at 4, 4. There's 1, 2, 3, 4. 1, 2, 3, 4. That guy's right there. What we're going to try and find is the distance between these 2 points. I'm going to do that in green. We're going to find the distance between these 2 points. Well, up to this point, we don't have a way of doing that. But what we do have is a pretty simple method for finding this distance right here and this distance right here. We can just count units, right? Here's 3 units. Here's, oh, that's not 4 units, that's 2 units. And that's 2 units right there. Well, now we've got a right triangle, right? We remember from geometry that when we're talking about right triangles, Pythagoras says a squared plus b squared equals c squared. So that's easy enough. We can plug in numbers. We're going to get 3 squared plus 2 squared equals c squared. Well, that's pretty simple. 3 squared is 9. 2 squared is 4. And that's going to equal c squared. Well, 13 equals c squared. Solving with square roots, we get 13's square root equals c. No simplification we can do with root 13, so there we go. This guy is root 13. We just found the hypotenuse of a right triangle. Now this is going to work with any 2 points that we can find, but we're going to have to be able to plug things in. Let's take a look down here at our distance formula. Make sure we've got this in our notes. If we go to plug things in, let's use that first point. That first set of points, rather. X sub 2 is 4. X sub 1 is 1. Over here, y sub 2 is 4. And y sub 1 is 2. We take 4 minus 1, we get 3 squared. We take 4 minus 2, we get 2 squared. We're going to take the square root of that. 3 squared, 9. 2 squared, 4. We get the square root of 13 equals c. So we see that these 2 methods agree. This is just an expanded form that will work with any 2 points that we've got. So let's go ahead and try it out on a couple of these. One more. All right, using our distance formula, which we've got here, let's try this out. In our first set of ordered pairs here, x sub 1, y sub 1, x sub 2, that's an x, and y sub 2. All right, let's try it out. Let's plug in under a big radical like so. We're going to plug in x sub 1 is negative. Oh, I'm sorry. We're going to start with x sub 2. Better follow the formula. We're going to start with x sub 2. That's going to be 4. We're going to subtract x sub 1. That's going to be a negative 3. We'll make that a plus 3. And we're going to square that. And we're going to add to that. We'll start with y sub 2. And that's going to be a negative 1. And we're going to subtract from that a 5. And we're going to square that. So 4 plus 3 is 7 squared plus a negative 6 squared. We'll make that 49 plus 36. 49 plus 36, guys, gives us an 85. And we're as simple as we can get with root 85. So that's pretty easy. Let's do one last one here. Thank you, calculator. I'm going to do this one. Let's make sure we got our parentheses where they belong. There we go. And let's do this here with our x's and y's. Our first set of terms we're going to start with a negative 1 minus 3. Let's square it. and we're going to add 5 minus the negative 3 is the plus 3. We're going to square that. Negative 1 minus 3 is a negative 4. Squared is 16. 5 plus 3 is 8. Squared is 64. We get the square root of 80. Root 80, we can break that up. Let's take out a 16. And 5. That's ugly, but we're going to get 4 root 5. Simplified, done and done. So what we found here is the distance between 2 points, this guy and this guy, or the length of a hypotenuse. So if we're asked to find the length of a hypotenuse, we can do that. If we're asked to find the distance between 2 points, we can do that. Very good. Well, say I've got 2 points and I want to find the point that's exactly in the middle of those, the midpoint. Well, we can do that too. And we've got a formula for it. So let's try this out. Here's our formula for midpoints. Now, keeping in mind, when we get an answer here, we're not going to have a length, we're going to have a point. We're going to have an ordered pair that we're looking for. All right, so again, x sub 1, y sub 1, x sub 2, y sub 2, and here we go. Let's start plugging in and see what we can find. Using these 2 points, let's use our midpoint formula. X sub 2 is 4, plus x sub 1 is 1, all over 2. That's our x coordinate. And for our y coordinate, we're going to have 4 plus 2 all over 2. And when we go to simplify, we're going to have 5 over 2, and 6 over 2, which reduces down to 3. So 5 over 2 and 3, there's our new point. That's the correct answer because we're in point form. Our answer is going to be a point. We're finding a midpoint. Let's do another one. We've got negative 5, 1 and negative 1, 6. Well, x sub 1, y sub 1, x sub 2, y sub 2. Let's go to work here. The first part of our coordinate, we're going to start with our x's. We'll add them together. Negative 1 plus negative 5 all over 2. And we're going to have on the other side, we'll have a 6 plus 1 all over 2. Let's go to simplifying. Negative 1 plus a negative 5, the same as a 1 minus 5. We're going to get a negative 6 over 2. And over here, 6 plus 1 is 7 over 2. Let's do a little simplifying. Negative 6 over 2 is going to be a negative 3. And 7 over 2 will leave in an improper fraction. We could make that into a mixed number. If you'd like to, go ahead and do that. All right, we've got one left. Let's do this. Negative 3 plus 0 all over 2. And on the right side, we'll have 4 plus 2 all over 2. Simplifying, we get a negative 3 over 2. We'll leave it in an improper fraction. And over here, 6 over 2, we're going to have 3. There's our answer. All right, that's distance formula and midpoint. Have fun.